All right, welcome everyone to the next installment in our review of correlation and data modeling. So we're told that the data are coded using the changes of variable x equal t and y equal log w, and the regression of line y on x is y equal minus 0.54 plus 0.124x. All right, so let's make this a little bit clearer. Y on x. So we want to write w in terms of t. Now, how we before we begin to answer this, notice here that we only have one log term. So this would be our semi-log model. And since there's a single L, we know that this will correspond to exponential. And the x here, so we know that we're going to have a b to the x, our standard approach, y equal ab to the x. Now they have swapped around x with t, so we're going to expect that we're going to have something of the form w equal ab to the t. So that's what we're looking for. So let's see how it would work. What we would do is we would swap y with log w. So log w equals minus 0.54 plus, and then we'd swap x with t plus 0.124 t. Now log w would be to the base 10. All right, so it would be assume that base 10 is the base that we're working with. So what we would do here now is I would cross exponentiate. So that's the term that I use to show what I'm doing relative to another concept that you'll be familiar with, which is cross multiply. So in order to now move from the log form to the exponential form, we're going to do the anti-log of everything. And one way of thinking about it is we're going to raise all of this to the power of 10. So 10 to the power of this is equal to that. That's what I mean by cross exponentiate. 10 to the power of that equals that. Therefore, w is equal to 10 to the minus 0.54 plus 0.124 t. At this stage, we can now leverage our knowledge of indices or the laws of powers and then split this up. So we know that a to the b plus c is a to the b times a to the c. So we should be aware of that. So now w is equal to 10 to the minus 0.54 multiplied by 10 to the 0.124 t. All right. So w is equal to 10 to the minus 0.54 and then 10 to the 0.124 and t on the outside, where that will be a, that will be b, and that will be t. So here, when t is equal to 0, w is equal to a. So a represents the initial value of w. So when t equals 0, 10 to the minus 0.54 equal initial w. So that would be like the initial population. All right, so let's put some, let's rewrite it so it is to some, it's in decimal form. All right, so 10 to the power of negative 0.54 is going to be 0.288. So we're going to have w equal 0.288 times, and then 10 to the 0.124, that's 1.33 t. So this is the initial population, initial value of w. And then how would we interpret the 1.33? Now cast your mind back to depreciation or compound growth in GCSE, and remember that 1 plus R formula. So this is what we have here is compound growth, where the rate of growth is 0.33. So so we have 33% as the annual rate of growth. So W is as an initial value of 0.288 and it's growing at a rate of 33% each time period. All right, so I hope that helps to clarify the techniques and the methods that may be associated with this standard of questions.